So registration is going to start in a couple of weeks. You'll start hearing about it. I believe information will be um, given out during social studies classes. So it might be a video that you're asked to watch or that your teacher shows you. It might be a Zoom meeting that for your class and the um, counselors might be in to give you some information. For math, it's pretty straightforward. Um, in order to move on to the next math course, you need to pass at least 2 trimesters of the previous course. So if you pass trimester 1 and you are going to pass trimester 2, then you would register for geometry. If you did not pass trimester 1, then you would need to excuse me, then you would need to pass trimester 2 and trimester 3 in order to take geometry. If you do not pass 2 of the 3 trimesters, then you retake intermediate algebra. So that's where we are with that. If you're doing very well and you would like to try honors, we can have that discussion. Generally, we look at students that got A's in intermediate algebra. That would be the, and want to pursue that track. And that would be a possibility as well. So we can have those discussions, like say, like after class, when we go into breakout rooms. If you have questions about it, feel free to ask. And if you have questions in the coming weeks leading up to registration, please ask. The process is going to be a little bit different. I think registration is all done online, but I believe you are going to submit to the counseling office a PDF of your registration form. So a couple of things that they're going to try to do a little bit differently with registration this year. All right. So those are the announcements. Let's get on with homework and notes. So again, we're on page 14 in your green packet. Excuse me. So we are going to solve word problems using systems of equations. And there are several different types. However, really they come down to a couple of main groups. And so we'll look at some examples from each of those kind of groups of problems and go from there. So the first thing is we have a process, just like everything else, roughly 5-step process. Step 1, label your variables to represent the quantities you're solving for. You should know what answer you're looking for before you even start. The second step, write 2 equations using the variables from step 1. The third step, pick a method to solve your system. Step 4, solve the system with the method that you chose. And step 5, label your answers using the labels in the problems. So I think it makes a lot of sense. Again, most of mathematics, very methodical. Start here and get to here. Example one, and one of the more common examples always deals with money. So in this case, Brenda and Adam are selling cheesecakes for a school fundraiser. Customers can buy pecan cheesecakes and chocolate marble cheesecakes. Brenda sold 13 pecan cheesecake and 9 chocolate marble cheesecake for a total of $305. Adam sold 12 pecan cheesecakes and 9 chocolate marble cheesecakes for a total of $294. Find the cost of each of the cheesecakes. So what I like to do is kind of mark up my problem. And for those of you who know who are in Avid and know some of the things with Avid, this is kind of the mathematical take on the Avid approach for marking up a problem. So the first thing I do, I go through and I circle all the numbers. So I have a 13, I have a 9, I have 305, I have 12, I have 9, I have 294. Then I underline the question, or I underline what I'm trying to find. A lot of times that's the very last part of the problem, is it just says find this or what is, and then you have to find what you're looking for. Excuse me. Box any keywords. So in this case, I think the pecan cheesecake and the chocolate marble cheesecake, might be keywords. The word total might be a keyword. And when I say keywords, I mean keywords for writing your equations and solving your system. Okay, school fundraiser might be a keyword for something else, but for the math problem itself, school fundraiser, probably not a keyword in this case. All right, then it comes equations. And so our variables first. I am going to use the variable P to represent the number of pecan cheese. I shouldn't say number. I'll change that. It's actually going to be the price or the cost. Not number. Cost. And C for the cost of the chocolate marble cheesecake. All right. So with that, I've got my two variables, and I think it might make sense that one of my equations is going to relate the number of cheesecakes that Brenda sold to her total, and the second one will do the same for Adam. So Brenda sold 13 of the pecan cheesecakes and 9 of the chocolate marble cheesecakes for a total of $305. Adam sold 12 pecan cheesecakes and 9 chocolate marble cheesecakes for a total of $294. So we've marked up our problem, we've read it, we know what we're trying to find. We've defined our variables, we wrote our equations. Now it's time to choose a method and solve our system. So, what method does this system seem to set up to use in order to solve that system? Should we use graphing? Should we use substitution? Should we use elimination? If you remember back to last week, we said we would use graphing if both equations were in the y equals form. Excellent. Which we don't have. Substitution, if one of the equations is solved for a variable, we don't have that. So elimination, and that was brought up in the chat, perfect. Elimination is going to be probably the method we use most often with the word problems. So the next thing I want to look at is which variable should I eliminate? So do I have variables that are have exactly opposite coefficients? And in this case, I don't. Do I have variables that are exactly the same? Ah, look at that. I have 9C and 9C. So what I am going to do, I'm going to try to eliminate the C's. And to do that, I'm going to take this second equation and I'm going to multiply by -1. I'm going to have the first equation is going to stay the same. The second equation, multiply everything by -1. And then I can add. So I have 13p minus 12p leaves me with 1p. 9c plus -9c is 0. That's eliminated. And 305 minus 294 gives me an 11, I think. Yeah, 11 looks good. So I already know I don't have to do anything else. I know the value or the cost of the pecan cheesecakes, $11. Now I would like to find the cost for the chocolate marble cheesecakes. So I'm going to take 11 and plug it into one of my two equations and solve for C. Again, it doesn't matter which one you choose. I would probably choose the second one because it does have a little bit smaller numbers. So if I take, 12 times 11, because that's what P is equal to, plus 9C, 294. 12 times 11 is 132. Subtract 132 from both sides. Excuse me. And then divide by 9. Again, if you would like, you could double check by plugging into the first equation now to check that 11 and 18 are the correct solutions. I am going to choose not to. But then we should label our answers. So pecan, pecan cheesecakes cost $11. Chocolate marble cheesecakes cost $18. And there's our first example. Any questions? Second example. So here's another example dealing with money, very common. The Simile Theater is putting on a winter play. Adult tickets are $8, student tickets are $4. They sell a total of 350 tickets. They collect a total of $2,000 from ticket sales. How many adults and how many students attended the play? So again, if I go through my process, circle the numbers. So 8, 4, 350, 2,000. Underline the question. How many adults and how many students attended the play? Keywords. Adult ticket, student ticket. I think that's those are keywords in this problem. I think the total of 350 tickets and the total of $2,000 are keywords. And now it's time to write our equations. Again, I think our variables are set up. We can determine what they are right away. I'm going to use A for the number of adult tickets. And I hate to use the letter S, but I'm going to. The only reason I don't like the letter S is it looks a lot like the number 5. All right. So we know that there are, excuse me, a total of 350 tickets sold. So the number of adult tickets plus the number of student tickets has to equal 350. And we know that each adult ticket is $8 and each student ticket is $4. And when I add up the amount of money collected, it has to add up to $2,000. So there is my system. Which method do we want to use to solve our system? Which one's going to probably work the best for us? So the method, yeah. So I think I understand the question now in the chat. Our options are graphing, substitution, or elimination for the methods to solve this system. So there are a few choices. You could use substitution. To do that, you would need to solve probably the first equation to get it in either S equals or A equals form. So let's go ahead and do that. You could use elimination. Elimination will always work with these systems, but let's try substitution. So I'm going to do it with substitution. If you like to try it with elimination, go ahead, and then we can compare answers when we're done. They should be the same. What I would do is take, if I was going to use substitution, I would take that first equation and write it down correctly. And I would solve for either A or S, it doesn't matter. Let's solve for A. So I'm going to subtract S from both sides. And now I can substitute what A is equal to into my second equation. So instead of A, I'm going to put 350 minus S. And now solve. So distribute the 8. 8 times 350 is 2,800 minus 8S plus 4S equals 2,000. Combining my like terms on the left-hand side there, I have minus 8S plus 4S So that would give me a minus 4s. Subtract 2,800 from both sides. Now be careful, I still have that negative with the 4s. And divide by negative 4. So I have s equals 200. Then I can plug in, and I'm going to plug into this equation right here, A equals 350 minus S, to figure out the number of adult tickets. So then final thing, they sold 150 adult tickets. Adult tickets. And 200 student tickets. All right. Next example. Excuse me. Find two numbers such that their sum is 25 and their difference is 1. Again, circle my numbers. Underline my question or what I'm trying to find. Box any keywords. I'll write my write my equations to find my variables. In this case, I would maybe just use x and y. X is going to equal one number. Y is going to equal the other number. All right, so it says their sum is 25. What do I do? What operation in math gives me an answer that's the sum? Sum means, there we go, all right. So sum means add. What about difference? If I'm finding the difference, what am I doing? There we go. Yeah, subtracting. Their difference is 1. Now, excuse me, the way that I've set up the two equations, x is actually going to represent my larger number, because if I take x minus y, I get a positive answer. It just happens that way. That's okay. Not a big deal. I think in this case, substitution might be, or I'm sorry, elimination might be the best method, because I have opposites for my y's. So we can just add. X plus x is 2x. Y plus negative y is 0. 25 plus 1 is 26. And we get x is 13. Plug in to either of my two equations to find out what y is. I'm going to use the top one. Subtract 13 from both sides. And y equals 12. And this one you could check, right? 13 plus 12 is 25. Yes. 13 minus 12 is 1. Yes. The check on that one was pretty easy. So to finish off, the numbers are, and I always like to write them smaller and then larger. So I would say 12 and 13. You could certainly say the numbers are 13 and 12. That would be fine. All right, example 4. Traveling with the current, a boat went 20 kilometers per hour. Traveling against the same current, it went only 4 kilometers per hour. What is the speed of the current? And how fast would the boat go if there were no current? So circle our numbers. Underline our question. In this case, we have 2 questions that we need to answer. Box any keywords. And write our equations. So we're trying to find 2 things. We're trying to find the speed of the current, and we're trying to find the speed of the boat. And even though this doesn't look very similar to the last example, It is exactly the same thing as the last example. We could have just as easily said two numbers have a sum of 20 and a difference of 4. When you're traveling with the current, you get the speed of the current plus the speed of the boat to give you your total speed. When you're traveling against the current, actually, I'm going to rewrite this first one because I want the variables in the opposite order. It's the speed of the boat plus the speed of the current. And against the current, it's the speed of the boat minus the speed of the current to get your speed. So just like the previous example, the sum of two numbers is 20, the difference is 4. So I can solve it the exact same way. Use elimination, add the two equations. B plus B is 2B. If you're into Shakespeare, it could maybe not 2B, I'm not sure. C plus negative C is 0. 20 plus 4 is 24. Divide by 2. And B is 12. Plugging back in and solving for C. So 12 plus C equals 20. So the speed of the boat is 12 kilometers per hour. The speed of the current is 8 kilometers per hour. All right. I want you to try this try now. And like I said, I'll give you some time, a few minutes, and then we can look at the answers. And maybe what I'll do is, as the time goes, I'll add a little bit kind of to the, maybe I'll mark up the problem and then I'll start with the equations. So you can just double check as you go. And like I said, then when we're done, we'll take a look at the answers. And if you need to, this would be a great time as you finish up, just stretch your legs a little bit. And we'll, like I said, we'll take a look at the answers here in a few minutes. All right. So using that system, I came up with answers. Blah. Nine students rode in each van. And 26 students rode in each bus. All right. Do the same thing with this next try now. Excuse me. So I'm going to mute myself here in a minute, turn my video off, and I will just go through each piece or add each piece kind of throughout the problem. So there were 155 people at a basketball game. Tickets for the game are $2.50 for students and $4 for adults. The total money received for admission was $492.50. How many students and adults attended the game? All right, in this case, if you solve this system, 85 students and oof, 70 adults attended the game. All right.